is up? Daniel here with the Virtual Robotics Studio, and we are back this time to build our intake base. So we're going to need a bunch of parts from that black crate in the kit of parts. But before we get started building, we're going to give yet another special thanks to Argosy, First, Aramco, and Team 302 for hosting our studio. The first piece that we need is the giant, this is a sheet metal, well, aluminum bent piece. It's got kind of these two tabs on the side. That's going to be the main structure for the base. And then I think in this bag, mine's labeled number 5, but there are 4 more of these aluminum really large angles. So we're going to need all 4 of those. I don't think we need anything else from this bag right now. But we will also need the 2026 KitBot hardware kit. And that one looks like it's from West Coast Products. So we're going to open that one up. And looks like there's a little informational card to learn some things about bolts. And what we are looking for right now is there's a few different sizes. First of all, there is the bag of 1032 thin lock nuts. We're going to need a bunch of those in this step and in future steps. I'm going to go ahead and pour those out into one of my bins. You can work from your bag if you have to. Then we're looking for the 1032 by 0.5 inch long button head cap screw. And those I'm going to also dump out into a little bin here. The other 2, we are going to put aside. We don't need those quite yet. All right. First step with this is find the side with the tab. So there are the 2 sides of this, sort of like bent. There's a longer side and a shorter side. The longer side also has these tabs on the side. And that's where we want to be attaching our first 2 of these angle pieces. Now, the orientation that these pieces go on does matter. So if you see, there are 3 sets of diagonal holes here. So 3 here, 3 here, 3 here, and 3 here. So 4 sets, sorry. And these are going to have positions for our angles to attach to them. But on each of these spots, it can attach facing this way or this way. And it does matter that we get them on the right orientation. So first, this side, the longer side with the tabs, right? That is the side that's going to be facing down. So the fuel ball is going to come up that edge first, and we want these to be facing in this manner so that they don't hit the leg of the angle. So they just hit the tall side and get centered in the robot. So we're going to take our front 2, and they're going to get attached this way, where the long sides are facing in and the short sides are facing out. And we're going to attach these with the bolts that we took out. And really, I mean, you can do 3 if you want. The official instructions, I believe, say 2. And I think 2 bolts here will also be plenty. Just make sure, they stay tight. So go ahead and get these nuts started. Now, one thing to keep in mind is these nylocks are, well, they're black, so that makes them a little bit different than the silver ones we've been using, but they're also thin, which means they have less threads on the metal side before you hit the plastic nylon part that we're going to lock into. That means that it is a little bit harder to get these started than the other ones, so just keep that in mind when you're going. So if you're trying to reach underneath here and screw it on and you're having a little bit more trouble, that is probably what is going on. All right, but let's get both of these started. I think that's on. All right, and then this one, because these are button heads, we've been doing socket heads until this point. Button heads are kind of rounded over and domed. They're really good when you need less or more clearance, so you need them to stick out less. They have a smaller Allen wrench size or hex key size. So these are not going to be 5/32, they're going to be 1/8. All right, and so let's get the 1/8 in there, and then lock in on the other side. And this is unfortunately an unpleasant position where you're going to have to turn it a lot. Maybe if you stick it up, you'll be able to turn it. That's kind of hard for me. best thing is if you have the handled Allen wrench, you can use that. And we can go ahead and make this one tight. The other option, of course, is if you get a socket out with a ratchet. My wrench actually has that on it, so I can use that as well on the bottom here. So get that wrench on. And now, there we go. We can do it that way. I think the handled hex key or handled Allen wrench is probably still the best way to go. All right, so that's one of them. And now we're going to do the same thing on the other side again so that the two short edges are facing away and then the flat sides are facing in towards the middle. So go ahead and get two of these bolts started here. And then two of the nuts on the other side here, get those started. There it goes. All right, and I'll flip this back over. Get the wrench on the bottom. And I think I decided I like the handled one the best, so let's use that one. And tighten that one down. All right, next, we gotta take a little sub-quest here before we can finish putting the other brackets on. And that is, on the other side here, we're not just going to put the brackets on. In fact, in between the brackets and our base ramp here, we are going to be attaching our KB26004. So this piece is actually going to be on here, sticking up. I think this is going to be some angle like this. But this piece is going to be attached on here and extending back to start building out the rest of our hopper. And this was the one, if you remember on the drawing, that when we did this, it said the 8X holes at the bottom of this part should be match drilled using KB26003 intake base plate, which is this metal piece. That is our intake base plate. So we are ready for that step. And what we're going to want to do is line this up on top of the metal plate, clamp it on, then we can flip it over and we can drill through those holes. Or we could put it on the bottom too and line it up and drill from the top. But I think it's going to end up going on top like this, so that seems like the better place for us to put it. So let me grab a couple of clamps here. Two is probably enough, but I'll grab a few extras just in case. All right. And the way that we want to try to align this is the edges should be relatively even. So if you kind of just feel the edges, just try to line them up. My plastic piece is just a little bit wider than the metal piece. That's okay. It doesn't have to match perfectly, but you can sort of feel if you press in from the sides that you're sort of following it and you're not, on a crazy angle. The next thing is we're going to push this all the way up until the point where the bend starts. So we're not going to go over the edge. You can kind of tell if you're in the wrong spot. If you can feel under this and you can start to catch stuff on it, that's a little bit too far forward. So we're going to go forward until it just sort of is like right on the end there as it starts to tip down. And once it's in place, we can go ahead and clamp it down. All right, so that one is starting. I'm going to check. That feels like it's, about at the curve there. Feels like it's level and straight. So we'll get that one attached. Let's attach one on this side. And because this piece is plastic, like I said, probably the 2 clamps would be enough to hold it in place, because when you start drilling through plastic, there's not that much force that's trying to move stuff. If this were a metal piece, attaching to a metal piece, I'd probably do more. You could probably get away with stopping there. I will add the other 2 clamps, though, because why not? I got them. So let's add one on this spot, too. And tighten that down. All right. And last check, right, because we're about to drill. The edges still feel even, and it feels like it's right on the end of that ramp as we go up this way. So I think we're pretty happy with that. We could do, if you know your piece is square, you could do an additional check. You could measure, from this edge here to the end of your piece in a couple different spots and see if it's on straight. But it's going to probably be okay, or maybe from this edge is even better. You can measure from this edge of the metal to the end of the piece. And we can do that. We can double check our piece. But know that if it is a little bit crooked, that is going to also be fine. Not going to be too big of a deal. So let's see. Well, I guess we'll go this way. All right. So for on this edge, got to tip it up a little bit. All right. I am just a bit, 7 and maybe a 16th. And on this end, we are, wait a minute. I am 7.5 plus a 16th, sorry. And on this end, I am 7.5 plus a 16th, maybe plus a 32nd on top of that. So that's pretty level, that's pretty even. Gonna be close enough for me. So now, we're gonna wanna flip this over, and we are gonna be drilling through not all of the holes, but some of the holes. So there are 2 holes that are bigger. These ones we're not gonna, oh yeah, we're gonna drill through those too, but they're gonna be a different size. So these 2 in the middle, those are gonna be 1/4-inch holes. And then these 3 on the side, those are for number 10 bolts. And there are a few different sizes that it might be. I'm actually not sure. Let's double check. So one common size for a through hole for number 10 bolts is a number 7 drill bit, which is actually 0.201 inches. That feels like that's probably exactly what it is. It's like a very tight fit. It might be one smaller. It might be a number 8 drill bit, which is 0.199. That seems to drop in really easily. So maybe that's what it is. But you can kind of use either of those sizes. So whatever size you have, if you have a number 7, use it. If you bought some number 7s, because that is a common size that you would use for 3/16 bolts. Number 10 bolts or 3/16 rivets, which are the most common sizes used. If you don't have any of the fancy sizes, you can drill with a 3/16 drill bit. Just know that your hole is going to be a very tight fit to the bolt when you go to put it together. And that's fine. I've definitely done it like that in the past. You might just have to, screw the bolt in to get it through the plastic, or tap it with a hammer to go through the plastic easily. So I'm going to do that number 7 drill bit here. And we will go ahead and line up and drill these holes. Now, the issue here is if I drill like this, it's fine if I stop, but I'm kind of pushing down on the clamps and the table is underneath where I'm drilling. So that's probably not like the ideal place to do it. Let's see, if we try to go off the edge of the table, now that I put those other pieces in, there's not like a great way to clamp it there. But if I go like this on the end of the table, then I'm pretty well supported and I can drill close by the table. And just like when we were initially drilling the holes in these parts, I can grab, a clamp here and squeeze that down to keep it from moving and have it supported. The difference with this one is because we're drilling into, let me see, I'm going to do these 3 and then I'll readjust because that one's in the table. Because we're drilling into metal this time, if the hole's a little farther off the table, we have a little bit more support. All right, so let's do that. We're going to basically just drop into the hole that's there and drill through. So that's 1, 2, and 3. Okay, skip the 2 big holes in the middle. And then we're going to do the 3 on the other side, but I got to move mine so I don't drill into the table. Okay, that looks good. So 1, 2, and 3 on this side. All right, and then the other one is going to be a 1/4 inch drill bit. So let me go grab a 1/4 inch here. Same one we used when we drilled a lot of the extra clearance holes on this piece. So that one's pretty easy. Let's get the 1/4 inch in. All right, and then I got to adjust this so that, the holes are off the edge of the table. So we're going to be way out a little bit, and I'll just clamp to the plastic just to help out a little bit. I would suggest, of course, if you have a second person helping you to hold this, they might want to hold down on this area a little bit to give some extra support. Okay, and we are going to line up in the first middle hole. And the second one. Okay, let's unclamp this. Bring it back up here. All right, the next thing we want to do is all of those holes. We've got some burrs sticking up. And yeah, we're going to cover them up with the plastic piece or with the angle piece. But the thing is, if there are burrs, depending on the size of your burr, when you go to attach this piece on there, it might not be sitting flat. It might be at this angle. It might be at this angle. And we don't want that. So we're going to go ahead and clean all of these holes up. And one thing that we might want to do right now before I unclamp it is the orientation that I drilled this is kind of important. Like if I took this plastic piece off and flipped it over, it might not line up, or it might be a little bit more crooked. So I am going to go ahead and put like a T kind of here in the middle for the top. I also know that my KitBot writing is on the top of this piece. So then I can unclamp this. And you might need to unclamp it more depending on how tightly you clamped it together. One of the things that can happen is some of these like shaving bits can end up like underneath there, like from the hole that you drilled. And if those are underneath there, then the plate won't be sitting flat. So it won't look exactly like that, but if you have some of those pieces, like if this plastic bent away, that can happen. Sometimes maybe if you push harder, it can do that as well. So we definitely want to make sure that we take it off and that that's clean. And then we're going to go ahead and do, so it's just these 8 holes that we just drilled, but we're going to use that deburring tool, or we talked about you could do it with any of the other style of deburring tools, and if you don't have anything, using a bigger drill bit would work to kind of knock these edges off. So this is on the side that's going to sit down on the plate. There are just small burrs here, and that means that it did press away from the plate a little bit. My clamps were farther away than they needed to be, or then they would need to be to hold it together. But of course, it would be really hard to get the clamps all the way in the middle of the plate. I would need some giant clamps. So that's OK. I'm going to turn it around, get the other side. So this is the side that we drilled on. This side, I definitely feel some burrs. So we'll get those cleaned up so that our angle pieces are going to sit nice and flat on top here. All right, and then I'm actually going to look at the metal piece where we drilled through. And I'm going to just feel around if there are any burrs that were raised up, or maybe they were left over from where it was made. But because we drilled through here, it's possible that we hit it. And actually, this one I felt a burr on, and this one I felt a little bit of a burr on. The other ones feel good. And then on the back, same thing. I'm just going to kind of feel around. I think some of the 1/4 inch holes snagged on the plastic when I went through and twisted my drill bit a little bit. So I got a little bit of a burr on both of those 1/4 inch holes. So we'll deburr those. The other ones feel pretty clean. All right, so now bring this back. I'm going to wipe off any of the plastic that was under there. I'm going to wipe off any of the plastic that's on the bottom of this piece as well. And then, if you remember, the T is facing up. That is my top. And for these, actually, we're going to go ahead and open the 1 inch long button head cap screws. So I think what you'll find is these ones, the 1/2 inch long ones, will just maybe barely be okay. going through all of this material, but it depends a little bit on how thick your plastic ended up being, whether it was the thicker or the thinner plastic. And then it's just sort of like maybe exactly enough to get through the nut. So it's a little close, and that's why I think first has us doing these not with the short screws, but with the longer ones. Now, of course, we're going from 1/2 inch all the way up to 1 inch long. We don't need that much more. If you had a 5/8, that would be great. If you had a 3/4 inch bolt, also would probably be better. Sorry, these 1 inch bolts, not those 1 inch bolts. Okay. But it's going to basically be the same thing we did before. It's going to be ramp on the bottom, plastic on top of that, and then our angle piece goes on top of that. Now, let's see. If you are facing the bottom of the ramp where we have already attached pieces, on your right-hand side, okay, what we're going to do is we're going to take the orientation that this piece is in, and we're going to rotate it around into this position. So these extra tabs are going to be facing towards the inside channel where the balls are going to be. It's another good reason why we have button head screws here, because we don't want the balls to get snagged up on anything that might be sticking out there. And let's get both of these started. All right, and again, so this piece here on your front right is going to rotate around, and that's going to be the new orientation for this tab. So these tabs are both facing the same way. All right, and we'll get it started. And now these are long. That nut started on the bottom of that one. There we go. And we have got a lot of screwing in to go here. I suspect that these ended up 1 inch because that is what the company had on hand to share. Because these bolts definitely can be shorter than this. You can see just how much they stick out the bottom when you finish this step. That's more comfortable for me. All right, here we go. All right, those two are tight. And now let's do the last one. And this one is going to kind of do the same. It's going to be the same way, orientation. So we started here, going in a circle. This is the correct orientation for this one. If you keep spinning it around, that's going to be the correct orientation for this one. Or in this case, the two tabs should be facing towards each other. And this one, they're facing the same way. On this one, they should be facing opposite directions. And again, we're going to use 2 more of those super long 1 inch bolts and drop those in to get them started here. And then see if we can get those nuts started on the bottom. And now we spin it 100 times. Well, that's not true. These are 10 32s, which means there's 32 threads per inch, and it's an inch-long bolt. So I guess the whole thing only has 32 threads. And we do have, like, 3/8 of material in between there, so it's just 5/8 of 32 spins. Oh, we made it. Of course, we got to do it a second time, so. Almost there. And tight. Okay. Whew. All right, I will mention too, as you're going to put these bolts in, if any of these holes don't line up, like if you did the 2 bolts on this side and you went to put these ones in and things just didn't quite line up, your plastic may have shifted when we clamped it up and drilled through. You know what? It's not a big deal. Just maybe add a clamp, or if you got 1 bolt in, you can just drill through whatever hole is left. And I guess we did drill the middle holes and we didn't even use those. So that was just some extra work. All right, so this ramp is almost done. We have one more piece that we need to attach in the middle, and that is our dead zone noodle. So we're gonna have a pool noodle there. And I think what it means is when a ball, let me grab one of these, is getting pulled up from the floor onto this ramp, and this probably would be a little bit off the floor, but that's hard for me to hold. When this is getting pulled up off the floor, we're gonna have a roller here that grabs it and starts pulling it in, or a wheel here that grabs it and starts pulling it in. And then there's gonna be another one farther back that's gonna grab it and keep going. But this spot in the middle might have good contact with one, but then it goes into the middle, the very center might just not have good contact with either the front or back roller. So there's no force that's moving it along. And so by putting a pool noodle or a section of pool noodle down here, what happens is when it comes in, the front roller is going to be squishing it into that pool noodle and still having contact. And then it's going to move over to the other side, and that pool noodle will be pushing it up towards the second roller. So by having something here that conforms, that squishes and moves around a little bit, that's going to help us handle what otherwise would have been a dead zone for the ball. So we need to grab our drawing for it. And I do have just a section of noodle here. Now you're going to need this 2.5-inch pool noodle. So this is 2.5-inch. Solid is ideal. You want to try to get the solid one, not the hollow one. They do sell them with a hole in the middle. There is a note that if you do have a hollow one, you're going to cut it a little bit differently, because that hole will, obviously fit around kind of the ramp here. So that's going to work different in terms of, the thickness that you need it to be. But if you get the solid one, that is the correct pool noodle, or the better pool noodle for you to use for your bumpers. So you're going to need a bunch of these for bumpers anyway. You might as well just get one, and we can take a 5-inch piece off of one of your bumper sections. So I've got this. We have a drawing for this part too. So this is KB 26017. Like I said, I guess this is the kit of parts 2.5-inch pool noodle. But dead zone noodle. All right. We have to make a couple cuts. First thing is we cut the whole thing down to 5 inches in length. And then we want about 0.8 inches of pool noodle that is going to be roughly the right height. And there is a note here. It says, note this dimension may need to be altered based on testing. So if we put this together and you find that that dead zone is still too much of a dead zone and it's not working, you might have to come through and instead use maybe the other half of this 5 inches that we're cutting off and cut it so that it's 0.9, or cut it so that it's 1 inch thick. That's going to give you more pool noodle sticking up, so it reduces the dead zone. The flip side is if you go to try to intake balls and they get stuck trying to compress the noodle and they can't compress the pool noodle, then you have too much pool noodle there. You'd have to go and shave a little bit off. But we'll start doing our best to try to get right around that 0.8 inches. and 5 inches long. Now the 5 inches long also not too critical because it's going to kind of go in between this area here. And if there's a little bit of a gap, well, the ball itself, right, can never, why'd I put the ball away? Can never touch the edges. Like if the ball rolls up here, there is no way for any part of the ball to ever touch that area where my finger is. So if this is a little bit shorter and there are bigger gaps on the side, it doesn't really matter because the middle is really what works. But we do have to make sure it's long enough that these 2 holes that we're going to use to zip tie it down can easily get around with some clearance there. All right, I think the first step is we want to cut this down to 5 inches. So let's measure 5 inches on our pool noodle. And I think what I'm saying by the hole, it could be off by a little. We don't need calipers for this. We can just do a measurement and take it out to that 5 inches. Guess it doesn't matter. We're going to eventually squeeze it down, so it's going to be nice and flat. So let's get a mark here at 5 inches. And I think it's going to be the edge of the line. So we want the line to be gone. And I'll put one more mark over there. That looks good. All right, to cut the pool noodle, you can do this in almost any way you want. I think you could probably even just get scissors if your scissors are decently sharp. Yeah, that cuts through it, no problem. I do think it's hard to cut. I think if I finish this out, it's hard to cut that straight. I definitely got quite a bit of wave in there. So that's fine, actually, though. If your end looks like that, it's not the end of the world. There are some wires that you can heat up that cut through. Those will give you nice straight cuts. If you have a saw, a hand saw, that's probably your best bet for this. You can cut it on the bandsaw too. It'll go right through. I have a hacksaw blade that I can try to use. So I'm going to try to just get that lined up right on the edge there. And I'm going to do my best to, what I think I want to do is I want to give myself another 5-inch mark. So I have something to aim for now that I'm through the first ones. So if I get another 5-inch mark here, and maybe one more on this side over here, if the tape measure would stay still. All right, another one there. Okay, so now I have something to aim for as I saw down. And then I'll look at this side when I go. You could probably also do this with, if you have those box cutters where the blade extends out and it's long enough to reach through the whole 2.5-inch noodle. But that is a pretty clean cut. And I think it's definitely straighter than the scissors were going to be. It's not perfect, but that's OK. And let's check it. I am just about 5 inches on that side, and I am about a 1/16 of an inch over 5 inches on that side. So a little bit crooked, but that's going to be OK. Now, that was the easy cut. The harder cut is this one. So we need 0.8 inches from one of the ends, and then we need to cut down through the whole thing. So I guess it's going to be, I'm going to use the same just saw blade that I happen to have. But in order for me to have any chance of cutting this straight, I need to find a way to mark down the edge on that line on both sides where I want to cut. So I don't know if there's a really easy way to mark this. I think one thing that might work really well is if we want it to be 0.8 inches. So if you had some bits of metal, anything that you could put down that was 0.8 inches, and if you had, if these were both 0.8 inches tall, and I could put the blade in between them, I could then, do this cut as we go, and just always keep my level with this between this and the table, between my bins and the table or whatever. Unfortunately, that is like an inch and, I don't know, inch and 3/4. See, that's it's pretty close to the other side being the size that I want. So that might actually work, crazily enough. Let's get a pair of calipers here, just so we can see. And I might want some tape, but let's see, if we measure the step here from the saw blade without it bending too much to the top of the pool noodle, and it's 0.945. It's a little bit too big. It's not like the worst. That is something you could try. But again, like if you can find two things that get you close, either so that the bottom is 0.8 or the top is 0.8 or close to 0.8, I think that's the best way to do it, because then you're guided the whole way through the cut. Instead, since I don't have that, let's see if we can find a way to mark it along the side. So if I have marks down both sides, then when I go to cut it with my hand saw, if I keep the top on that line and the bottom on the bottom line, then I know I'll be cutting relatively straight. I think if I just try to eyeball it and I start here, I'm going to be way off on the other end, one way or the other. So let's see, how else can we mark this? So also, if we can get the pen, if I can get my pen off the table by that 0.8 of an inch, then I can drag it along the side of the pool noodle. The other problem is I can't pass the pool noodle past it because I need the hole on the other side without rotating the noodle at all. So I do think one of the things we're going to have to do with this noodle is we need it to not move. And one of my thoughts would be like, hey, if I put it on the end of the table and I clamp it, that kind of works, except the problem is if I clamp it, now it's squished, so my line at 0.8 is gonna, once it springs back up, is not gonna be in the right spot. So we can't clamp it with any force. So I think, let's see if we can get some tape to kind of hold it in place. And I wonder if, so maybe I can do, well, let's see, if I put anything under it, that's also gonna change the dimensions. So what if we take some tape down the front like this, and also down the back, and really do my best to square that tape up. Okay, that moves a little bit, but I think that's gonna be good enough. And again, I mean, I'm probably overdoing this, or this probably doesn't have to be that accurate, but I just don't know how I'm gonna cut on a straight line. Then our next step is gonna be to get something to hold the pen. So if I can have the pen on top of, again, like if it were this box, if this box were the right height, I could just drag my pen along, do the same thing on the other side, and that's gonna be good enough. But obviously that box is way too tall. Let me see. That's gotta be over 0.8. What about this? So if I'm on the edge of this, what height is that gonna be? We can sort of test that. Let me get my tape here, and I can actually go ahead and mark on the tape when I drag through. So if we do one of those, then let's see what that dimension is. So I can actually measure that. And so that's close. That's really close. To the top of my mark, it's 0.776. So I bet you if I just took maybe one piece of tape, maybe two, and if I just took the end here that we were resting on and put it on that tape instead, I guess I really want to be, I don't want any of this sticking out the front. That should make us a little bit taller. Let's see where that puts us. So again, I'll mark on the roll here. Can probably even use the last bit of tape to hold it in place. All right, so if we measure that, that is that's 0.8 to the top of the line. That's perfect. All right, so actually, I'm just gonna kind of tape my pen in there, and that is my marking tool. Now, if you have a square like this, that could work. You might be able to like even adjust it, because this is on an angle, right? So you might be able to adjust it if it's not exactly in the right spot. Or again, find something else that's gonna let you set your pen to 0.8. And now, all we have to do is take this over to our pool noodle, and we're gonna just drag it all the way along this side. And I'm pushing as little as possible because I don't want to rotate the noodle or squish the noodle or anything like that. Obviously, you got to push into it a little bit. And then all the way down this side. And basically, I want the line to stay. I want to cut above the line. And that should give me really close to 0.8. So I think I'm going to untape this so I can see what I'm doing here. All right, so now we'll get that saw blade, and I'm going to start just outside of the line on this edge, and just outside of the line on that edge. All right, and that looks like I'm maybe a little bit too outside of the line on that edge, but that's okay. And actually, I'm going to go ahead and cut down along this line. Just on the one side, that's going to give me a good starting line on there. And then we're going to be able to cut on this line on the other side. Now I'm going to look back on this side. And maybe I want to hold the side that I'm cutting on. All right. And I'll watch this side as we go. Or actually turn it around and watch this side as we go. And then, well, we're at the end, so it's going to be what it's going to be. All right. We've separated a piece. Is it at all close to 0.8? Boy, I hope so. Yeah, I'm getting 0.778 on that side. And then on this side, I'm getting, well, this side looks a little better. I'll spin it around. This side, I'm getting 0.879. Depends on, it's really hard not to squish the foam at all, but I think this side is really close to 0.8. That's probably going to do it. That's going to be good enough for what we need here. All right. If you are using a hollow pool noodle, I think there is a recommendation in the instructions. Instead of cutting it, we're essentially cutting it in thirds, right? This is 2.5 inches, and we're doing 0.8, 0.8, 0.8. It's a little under a third. If you're doing a hollow pool noodle, I think they said to try cutting it in half because it's going to have more squish, and some of that cutout part is going to fit around the corner of the ramp. Okay, so save this, right? Because remember it said that you might have to do some testing, you might have to adjust it. Well, we definitely can do another one on the other side. So if we find out that we need a little bit more, we can repeat the same process, but try to maybe add some more tape or add something else underneath to get a higher number. We could do 0.9 or 1 inch that way. So this is really good for us to use for a second one. You might also find that if it's just a little bit off, you might be able to cut, like on this flat side, you might be able to just cut like a little sliver of like, I don't know, 1/8 of an inch or something like that, and cut that, and then be able to take that sliver and still stack it underneath. So that might give you a chance to make adjustments without having to start all the way over from scratch. All right, let's get this attached to our ramp over here. All right, move all this other stuff out of the way. All right, bring the ramp back. This is going to sit right in the middle here, and we're going to hold it on with zip ties. So I've got some, these are actually pretty long zip ties. I think the ones that came in the gray tote are going to be long enough to make it all the way around, but if they're not, just know that you can connect zip ties together to make them a little bit longer. But we do have one issue. If I put this in this direction and attach it, when I'm done, this bump is going to be on the top surface where the ball goes by. We don't want that. So with your zip ties, we're going to take both of these. We're going to start them from the bottom where our bolts are coming through here. So we'll come from the bottom through, and then we're going to pass it back through. And depending on the size of your zip tie, you can probably get it started now. And again, through, back through, and then I will go ahead and get this one started as well. These are super long. I probably could do much more than that. All right, then on the other side, we can take our dead zone noodle. And I'm going to basically just do my best to center it in the area we talked about. It's not super critical on the edges, but just so to make sure you have the same amount of room to either side of the zip ties. And then we're going to kind of hold it there and pull the zip ties tight. Okay, and you can see I'm not super tight yet, and I can see I'm off a little bit, so I might try to slide it and shuffle these over, just so it's back towards the center. And then the instruction here is that, yes, we want this to be relatively tight. We want to pull down to squeeze this down a decent amount so that it's not going to move. So I pulled not quite as hard as I could pull, but pretty hard to get this in there. And you can see that we have kind of like it's puffing up, and this is not going anywhere. All right, now we've got these sharp ends here sticking out the back. We want to clip those down so that they're not in the way. And there are a couple different tools that you can use for this, but the best tool is the flush cutters. So if I were to use, like, for example, my scissors would cut it. I could go down there and I could cut it with the scissors. The problem is I can't cut right flat on the edge of the zip tie, so it's always going to leave this really sharp edge here that you can get poked with. So the cool part about the flush cutters is one side is flat, so you can go all the way down till it's touching, cut, and now there's nothing there. There's nothing there to get poked on or scratched on. I've definitely had robots in the past where we did not have flush cutters, and I got my arms all scraped up from reaching inside the robot. So that helps a lot. If you don't have flush cutters, you can, after you cut it, right? If you cut it up here and you've got this really sharp pointy end, you can actually hit that with a lighter and melt it a little bit, and then you have something that's not sharp. So that is another option, but the flush cutters are the best, and they're not that expensive. All right. Check this out. So this is in. So the ball is going to come in, right? And we're going to be able to squish that noodle down. So between the ball and the noodle squishing, we should hopefully not have a dead zone there. And then back into the hopper of the robot. And then from the hopper, it'll go back out up through the shooter. All right. That looks complete. I think our intake base, our intake floor here is done. We're going to clean this up, bring the frame of the robot in, and let's just get this attached to the robot because that is what goes on next. So we'll be right back. All right, we're back with the frame, with our chassis again, and our bottom intake, our base intake here. And this is going to go on the side with the cutouts, of course. It's going to drop in between. So these tabs are what we're going to bolt to. Got those tabs bent down on each side. So this should slide inside your frame here. Looks like it's a little bit of a tight fit. We talked about this with these churros crossing the frame and how they really need to be 18 inches. If they're a little bit too short, maybe adding those washers. So if you can't get this to fit in, check the measurement, see if you're 18 here. If you are, you might be able to like bend these tabs in a tiny bit. But you can also see like if it goes in this way, at the top of the tabs, then you'll know maybe the tabs aren't bent in enough. But if the top of the tab where the bend is too wide, there's nothing you can do about that. And so you're going to need to extend your churro pieces out. And that's by adding a washer or two on each side of your churros. But if this drops in nicely, then you are ready to attach it to the frame. So this one is a little tricky. We're going to take a look on the side here. And we have our outside frame rail attached. So one of the things that you can do is if you have to access this stuff, you could take this outside frame rail off. Unfortunately, that means taking off the 4 churro bolts, undoing the wheel bolt, undoing the 3 bolts on each side. Then you can take it off. Then you have to redo all of that. Now, I think we can access everything. We shouldn't have to do that. But what we are looking for is we're going to come really close to the churro here where we're going to attach. And let me see here if I can get it lined up right. Yeah, OK. So if you go next to this churro bolt, and I'm going to show you on the outside frame since that's visible, but we are going to be attaching this on the inside frame here, not on the outside, but the hole patterns are the same on them. So let's look at this outside frame to get the place we're going. So we have this churro bolt here. And next to it, there is 1, 2, 3, 4, 5 number 10 holes kind of in this pattern. There's a row of 3 and a row of 2 next to the churro bolt. We're going to end up bolting in kind of a Tetris piece pattern. So we're going to be here, 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 a Z shape, as it were. So we're going to use these 2 holes and these 2 holes, but on the inside frame to attach this one. All right, so if we look at the piece, if I pop it out, there is your Z shape. So this is going to be the top hole next to the churro bolt. Then we have the 2 in the middle, and then 1 hole down on the bottom. And I think for this, I think that if we tip the robot up, reaching underneath, it's going to be easier to have the bolts go from the inside out. And when the wheel is in here, if you had to unbolt this or tighten things, it's going to be hard to get the Allen wrench through because all the wheel stuff is there. But I think it'll be easier, or possible at least, to come up from the bottom with this wrench flat against the wall to be able to get to the nut. So I'm going to start with the bolts on the inside, and I'll put the nuts on the outside here in the frame rail. And we're going to be using the same ones that we did for the first 2 angle pieces we put on. So that is the 1/2 inch long, so the short 1032 button head with those little skinny jam nuts. All right, let's see how we can get access to this. Let me try just tipping this all the way up on its side. I think that's going to work the best. And, well, now it is a little hard to see the top one. I can see the bottom one really easily, though. So actually, instead of working on the top, let's do the bottom section first. And I'll be able to kind of get that Z lined up down here. That looks pretty lined up. So I've got my Z shape here lined up with the holes below it. And I'm just going to try to drop a bunch of bolts in right now to kind of get it in place here. And one more up here. Okay. So I think, like, even when the robot is done, the electronics board is going to be on the back. So there's nothing, like everything else is back here, so there's nothing right in this area, which is where we need to put our tools to be able to attach stuff, right? So I think we'll always be able to go in with an Allen wrench like this. And then even if a wheel is here, especially since we put the belt to the outside, we should be able to go up from the bottom to try to find a way to get the nut set, or to get the wrench on the nut. So we'll be able to tighten these up, or even if we had to, take it out without removing the wheel. Although it might still end up being faster to remove the wheel. All right, so I'm going to get that one started. Now the one problem is that there is not a lot of room here to tighten these bolts down. So we're going to have to do this a number of times. And one thing that might help is you can move the wrench on the bottom to kind of reset it. And then you can put the Allen wrench in. You can then pull the Allen wrench all the way and turn the wrench all the way, so you get kind of 2-for-1s. That said, still going to take a few attempts. I think also it's slightly easier to take the wrench off the bottom and reset the Allen wrench than it is to take the Allen wrench out and put it back in every time. And this top bolt, I think, if you have a small socket, it might fit on there. I know the socket on my wrench does not fit. That's why I'm doing it this very slow way here. All right. Maybe one more, and we'll say that's close enough for now on that one. Now some of these other ones are going to be much easier because they're a little bit farther away from the edge. So let me get the nut started on, just start the nut on the other ones. You might want to not do this. You might want to wait because with the bolts sticking through, obviously they're hitting my wrench on the bottom. But I definitely want a few of them in just to make sure the alignment is good when we got started here. So now I do think I can use the ratcheting part of my wrench, or if you have a socket set, that's going to be great for this hole. Still not the most amount of room to work with, but it's going. All right, let's get the next one. And I'm leaving all of these bolts loose until we get the other side started as well. All right, so one more here. Oh, and this one, we have all kinds of space. Okay, actually tightened that one a little too much, so I'm going to loosen it up a little bit. All right, looks good. Now, on the other end, let me see. I think I'm going to have to flip the robot over because I'm just not tall enough to see what's going on up there. So let me flip it this way. And we got kind of the same situation down here that we had before. Okay, so this time, let's be a little smarter. Let's do just the top hole first and get that close, and then we won't have to do quite as many turns when all of the other bolts are in the way. So get the nut started on the bottom there. The Allen wrench in and the regular wrench. So we'll turn it, take the wrench off, reset, put the wrench on, and just keep doing that until it's close. Okay, that one's close. We'll get the next one started. And now we get to use the ratchet. That one's close. And once again, get it close but not tight. And let's drop that last bolt in there. And this one, because it's the last one, we're ready to now start tightening them all the way. So we might as well start with this one. And then we'll work our way through tightening all the other ones. Looks like I left this one looser than I should have, but almost there. Yep, that one's good. All right, let's see, we can push this through. I think now, with it on this side of the table, I can see the top, so let's go ahead and leave it in this orientation and get the Allen wrench in on the bottom. All right, and we can tighten, reset, tighten a little more. It's like this one is very close to tight. After the bolts are started, I think I like this direction better. Easier to see what's going on for me. Okay, and then the last one, which is the loosest one by far, unfortunately. There we go, we're in. And you can, on this one, have the wrench on a little bit of an angle, so it clears the other bolts and nuts that are in here. And that is in and tight. All right, let's flip this robot back to the direction it's going to be. All right. Looks good. And let's see now. We can sort of visualize we're at this point. So this, we're going to have that roller going across the front. It's going to grab the ball. It's going to center it on those things and then climb up over this back into the hopper. Obviously, we have more walls that need to get built onto the hopper. Then it'll feed back from the hopper up and out of the spinning launcher wheel. All right. This looks good. We have our bottom floor here completely assembled and attached to the frame. So we are done for this video. We're going to come back in the next one and start working on that intake assembly. All right, we'll see you in the next video. But before we go, we're going to give another special thanks to Argosy, First, Aramco, and Team 302 Lake Orion for hosting our studio.